my channel. Hope everyone is doing great. Let's solve today's Leetcode problem 2598, smallest missing non-negative integer after operations. You are given a zero index integer array nums and an integer value. In one operation you can add or subtract value from any element of nums. For example, if this is nums and values 2, you can choose to subtract value from 0 and make it as -1, 2 and 3. Okay. The MEX minimum excluded of an array is the smallest missing non-negative integer. Okay. They are looking for a smallest missing non-negative integer. For example, in this, what is the smallest missing non-negative integer? Here it is 0. Okay. Whereas here it is actually 2. Okay. Because 0 is present, 1 is present and the next missing element is 2. So, 2 is answer over here. Okay. Here the first non-negative integer is 0. 0 itself is missing in this given array. So, 0 is the MEX here. Okay. Return the maximum MEX of nums after applying mentioned operations any number of times. Okay. We have been given a freedom that you can apply any number of times, that addition or subtraction you can do it. Okay. So, let us look at the examples which I have given. When I was actually going through the examples, I have noticed some unique behavior. Okay. So, if you see, one was, I'm just going here. Okay. If you see, one does not change over here. Okay. The 10 got changed to 0. Okay. In the next iteration, 7 got changed to 2. Okay. And then these are all the same case, same approach which they have used for the explanation. Sometimes giving attention to their explanation also will give us some kind of hints. Okay. So, 7 was moved to 2, 13 was moved to 3. Okay. If you see, can you derive any pattern from this conversion? Yes. So, if you guessed that modulo is the operation, then you are correct. Okay. So, -10 modulo 5 is actually 0. 7 modulo 5 is 2. 13 modulo 5 is 3. Okay. So, every time they are taking the remainder of each element by dividing it with 5. Okay. By dividing it with the value. Okay. We have to be careful when the remainder turns out to be negative. Okay. Since our aim is to identify the non-negative integer, okay, first missing non-negative integer, we have to make sure that our remainder remains positive. Okay. Let us say if -13 is part of the given array, if you do -13 modulo 5, that will give you 3. Okay. But since our aim is to find the positive integer, we will make sure that the remainder is turned to be positive. Okay. So, the remainder would be 2. Okay. So, let us continue this. 6 ka remainder 1, 8's remainder is 3. Okay. If you see, this is the final array we got. Okay. Now, idea is to find the first missing number. So, 0 is not a missing. If we assume the first missing number is 0, that means 0 is present in this. So, 0 is not an answer. Next 1 is not an answer. 2 is not an answer. 3 is not an answer. Is 4 an answer? Yes, 4 is an answer. Okay. Because 4 is missing over here. Let us say 4 was also present. Will 5 be an answer? Yes, because 5 is not there, that will also be our answer. Okay. So, idea is keep the frequency of the remainders. Okay. Let us have, for the given example, we have frequencies as 1 has occurred twice, 0 has occurred once, 2 has occurred once and 3 has occurred twice. Okay. So, we will assume the first missing number is 0 and we will check whether 0 exists in the frequency array, frequency matrix or not. Yes, 0 exists in the frequency matrix. So, 0 is not an answer. Okay. So, I can remove, I will basically decrement my counter of 0. Okay. So, since it was only 1, so the counter will become 0. Whenever a counter of a particular frequency becomes 0, I will remove it from the I will remove it from my frequency. Okay. Okay, now next the missing number is 1. We'll increment our missing number to 1. So does 1 exist in our frequency? Yes, it exists, but it exists twice. Okay, so we'll just decrement it. Okay, we'll decrement it as long as it is just greater than or equal to 1. Okay, if it is, when we after decrementing, if it is become 0, that means we don't want that element to be present in our hash map. Okay, so here since we have only decremented it once here, so there was one more element which can be mapped to 1. Okay, next we move it to 2 exists in it. Yes, 2 exists. Now we have to decrement it. Since we have already encountered 1, 2, we don't want to encounter the same 2 again, so we'll decrement it. Okay, we have already utilized one of its we already utilized one reminder 2. Okay, now we will move to 3. Does 3 exist in this? Yes, it exists, so we'll decrement it. Next we'll go to 4. Does 4 exist in this? No, it does not exist. As long as we encounter a first number which does not exist in this matrix, that will be our answer. Okay, let's say we have also have 4 over here. Let's assume 4 was also present. Okay, for some different test cases, let's assume that 4 also exists. Since 4 was present, we'll decrement the 4. Okay, next we'll move to 5. 5 does 5 exist in this array, in this frequency matrix? No, so we'll return the answer. So whenever we encounter a number which does not exist in the frequency matrix, then we'll remove it. The other approach is, instead of playing with this, you can also keep an extra boolean array of size equal to the input array. Okay, and then you will just iterate through each of these frequencies. Okay, and then mark them as true. Okay, initially every element will be false, 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 false. Okay, I'm just telling you another approach. Okay, if you follow the first approach, then it's fine, you will be able to complete the answer. There you will only take the extra memory which is equal to the size of the hash map, which will be order of value, whereas if you follow this approach, the space complexity will be order of big of n. Okay, so yeah, here we'll consume some extra space because we are actually constructing this extra array altogether. Okay, so let's go through it. Okay, we'll take the first key. Okay, so one exists in the array. So 1 exists in the array twice. That means there are 2 numbers. Okay, 1 can actually exist as 1, or it can also exist as 1 plus the value. Okay, so all the numbers. Okay, if you see frequency times the value. Okay, where frequency will actually go from 0 till the f, matlab actual frequency value. Okay, let's take it as I, so you won't be confusing. So if we have a frequency of, let's say we have a number 1, okay, reminder 1, which has a frequency equal to frequency, that means there is a possibility that all these possible values can exist in the array. Okay, so let's take it. Okay, 1 plus initially let's assume frequency if I value is 0. Okay, so 0 times the value which is 5, so this will turn out to be 1. Yes, 1 do exist standalone, right? Next value is 1 plus 0, 1 times 5, which is 6. Yes, 6 also exists, right? 1 and 6 both exist in the given array. So that is how we are actually backtrack calculating it. We'll go all the way up to frequency minus 1. Okay, and we have to also make sure that since we are only taking size equal to the input size, we also have to make sure that this index is not getting out of bounds. Okay, if it is out of bounds, we don't have to process it. Since we don't have to process it. Okay, now the next we went to 0. Okay, uh, 0 exists, so we'll mark 0 as true. Next 2 exists, we'll mark 2 index as true, and then 3 exists twice, so we'll mark 3 as well as true. 3 was marked, the next 3 will actually go out of bounds, so we won't process it, and then we'll just iterate through this array, and whenever we encounter the first false, that means that particular index is missing. Okay, so this is another approach. Okay, but the best approach is actually to follow this particular array and decrement the counters and accordingly find out the missing element. Okay, I hope this explanation is clear. Let me go through the code which I have written. Okay, so here I have mentioned initially we will be having an array called frequency. We'll have a hash map called frequency where we will actually track the frequency of the reminders. Okay, this will go all the way up to order of value. Okay, I just defined a variable n is equal to length of this, and then I'm just iterating through the array and calculating the frequency reminders ka frequency. Okay, so I told you, right, there is a possibility that the reminder can be negative. So in order to handle it, first I'm just calculating the reminder. Okay, if the reminder is less than 0, I'm just adding a value to it so that this will become positive value and it will write between 0 to value minus 1. Okay, the same thing can also be done using this one line of code. Okay, here what we are doing is we are just taking this reminder and adding a value to it. Okay, whenever nums of I is less than 0, that means this will be negative and we are trying to make it as positive. If this nums of I is already positive, adding a new value to it, adding one more value to it will not be a problem, because since we are taking modulo, this will actually turn out to be 0 and then the remainder value still remains the same. Okay, anything is fine, you can follow any approach. Okay, and then I'm just calculating the frequency. Since we have the frequency matrix in present, we'll assume the first missing number is 0 and we'll check whether the missing 0 is part of my frequency matrix or not. If it is part of my frequency matrix, that means I have to decrement the frequency of that particular number to I have to decrease it by 1. Okay, and then I will increment my missing by 1. Okay, and I will keep on repeating this process until and unless I found a number which is not present in my frequency matrix. That means the current number is not part of the missing. Then that is our answer. Okay, let's try to submit this. As you can see, our solution is pretty efficient. Let's try to analyze the time complexity and space complexity over here. Okay, so here we are trying to generate the frequency hash map. So this would take a space complexity of order of value. Okay, because since the remainder can only lie between 0 till value minus 1, so that is the reason it will take order of value. And then we are just iterating, we are initiating the missing value to be 0 and iterating until unless we are not finding the missing value. So this would run as long as this would run all the way up to order of n. The reason being, since we have n elements in the array and if all the elements were unique, okay, let's say all the elements were unique, let's give an example as 1, 2, 3, 4, 5. Okay, so each and every element has a frequency of 1. So our missing will be also, we will be iterating for each and every element and reach all the way up to 6, and then 6 would be our answer in that case. Okay, so yeah, that's all about this problem statement. Do subscribe to my channel for more such coding videos. Thank you.